Welcome to the Explainer. Usually, we kick things off with a standard agenda to set the stage. But today, yeah, we're skipping all of that. We are jumping straight into a profound, literally, existential shift that is completely rocking the mathematics world right now. The very ground beneath academic research is shifting, and we're going to trace exactly how it just happened. Okay, let's dive right into this. 2. That's it, 2 hours. That is the shockingly brief amount of time it took an artificial intelligence to completely obliterate the barrier to entry for mathematical research. We aren't talking about years of grueling study or months of back-and-forth peer review. We are talking about 2 hours. So what exactly went down in those 2 hours? Well, ChatGPT 5.5 Pro actually produced a full PhD-level mathematical research. Now, I need to be absolutely clear here because this is crucial. This is not about an AI just acting as a super-powered search engine, right? It wasn't just regurgitating existing proofs or finding some known trick buried deep in the literature. No. This is about an AI fundamentally changing the game by generating completely original, high-level math. Section 1. The ChatGPT 5.5 Pro experiment. So, this whole experiment kicks off with Timothy Gowers. He's a brilliant mathematician and a Fields medalist, which, if you didn't know, is basically the Nobel Prize of Mathematics. Now, Gowers had been watching these large language models solve basic math problems, but he decided it was time to really push the limits. He wanted to rigorously test this new ChatGPT 5.5 Pro model with something way more challenging. So he deliberately fed the AI open problems from a paper by Mel Nathanson on additive number theory. And why this specific paper? Well, because the problems were relatively new. Gowers was looking for a real challenge, something that couldn't possibly just be scraped from the AI's existing training data. He wanted to see if this thing could genuinely reason its way through a totally fresh mathematical landscape. Now, before we look at how the AI actually performed, let's quickly ground ourselves in the math. The problems here revolve around something called a sum set. Simply put, if you have a set of integers, its sum set is just the set of all possible sums you get by adding two elements from that original set together. Simple enough, right? But mapping out the possible sizes and limits of these sets, yeah, that gets incredibly complex, incredibly fast. So Gowers throws this question at the AI, and almost immediately, the AI finds a quadratic upper bound for the problem by using a more efficient mathematical structure known as a side and set. But honestly, what's truly mind-blowing here isn't just that it found the answer. It's that when Gowers asked the AI to write up its argument, it instantly spat out a perfectly formatted LaTeX document. That is the standard, highly technical typesetting language that mathematicians use for their preprints. Just instantly. And this brilliantly illustrates the sheer, frankly absurd speed of what went down. Check this out. 17 minutes to solve the initial sum set problem. Later on, it took just 16 minutes to improve an existing exponential bound. Then 13 minutes to achieve a groundbreaking polynomial bound. And finally, 31 minutes to write the whole thing up into a complete, mathematically accurate preprint. I mean, in less time than it takes to watch an episode of your favorite show, this AI sprinted through escalating major mathematical breakthroughs. Which brings us to a really crucial point from Timothy Gowers himself. He explicitly stated that the AI produced this PhD-level research with no serious mathematical input from me. I really want to highlight this because it perfectly validates the AI's autonomy. This wasn't some case of a brilliant human dragging a machine across the finish line with heavy-handed prompts and hints. The machine literally ran the race all by itself. Section 2, an original AI idea. All right, this is where things get undeniably real. Enter Isaac Rajagopal, a wildly brilliant MIT student. Isaac had recently proven an exponential bound for a specific sum set problem. So Gowers feeds this exact problem to ChatGPT 5.5 Pro. And the AI didn't just tweak his work. It massively improved the upper bound from an exponential dependence to a polynomial dependence. Now, in the math world, moving from exponential to polynomial, that is a massive leap in logic. It absolutely requires finding entirely new parameters and building sets that behave in really counterintuitive ways. So when Isaac Rajagopal actually sat down and reviewed the AI's preprint, this was his reaction. To do this, ChatGPT came up with an idea which is original and clever. Think about that. That is a stunned human reaction from the original author himself. He even admitted that this was the kind of idea he'd be incredibly proud to come up with after a week or two of deep pondering. And the AI? It found it in less than an hour. So, the million-dollar question is, how did the AI actually pull this off? Well, Isaac provided a really great accessible analogy for the AI's aha moment. He explained that the AI somehow managed to squeeze half a geometric series into a polynomial interval.
It did this by utilizing what are called k-dissociated sets to perfectly control the mathematical relations. It's a highly ingenious, completely original application of algebra to additive number theory. Just brilliant.
Section 3. The End of Gentle Problems.
Now, what's really interesting about this shift is that this breakthrough doesn't just stay on the chalkboard. It is spilling out into the real world, creating a very stark contrast between two eras in academia. You see, before large language models, when a new PhD student started out, their advisor would typically hand them gentle, unsolved problems. It was a nice way to learn the ropes, build some confidence, and secure that first publication. But after LLMs, those gentle problems are entirely gone. They are going to be swept up by AI in a matter of minutes. The new, incredibly daunting baseline for a human to contribute to math is proving something that an AI simply cannot.
Which, as you can imagine, leads to a massive logistical headache. What exactly should the academic community do with this AI-generated, perfectly publishable mathematical content? If a human had written this 31-minute preprint, it would absolutely be published in a major journal without hesitation. But platforms like arXiv, they currently have very strict policies against AI-written content. So where does this valid, accurate, and undeniably useful research actually live? The community is literally scrambling right now to figure out how to moderate and store these AI discoveries.
Section 4. The Future of Human Math.
So if an AI can generate original, clever, PhD-level proofs in an hour, what is the point of human mathematics now? Well, Timothy Gowers makes a strong argument that we shouldn't despair. Instead, we need to adapt. Humans absolutely should still struggle with hard math problems. Why? Because doing that hard work gives you deep foundational insight into the problem-solving process. It actually equips you to effectively guide and collaborate with these AI models. It builds highly transferable skills. Think of it like this. Knowing basic arithmetic is exactly what allows you to instantly spot when a calculator throws out an error, right? By continuing to do the hard math, humans are going to become elite vibe coders and brilliant directors of AI intellect. But it really does leave us with a deeply provocative thought experiment, and it's something I want to leave you pondering today. If a human mathematician sits down, guides an AI through a few prompts, and then the AI does all the heavy technical work and generates all the main clever ideas to solve a major historical math problem, is it still the human's achievement? Who actually gets the credit? Who gets the immortality in the history books? It's a massive question that goes far, far beyond just math, and it's one we are all going to have to answer very soon. Thanks for joining me on this explainer, and keep questioning the baseline.